Hello and welcome everyone. In this day 42 learning of greedy strategy and application, we are going to be understanding what a greedy algorithm is. So, in simple terms, let's say we are assigned with a bunch of meetings. The best way to go about is, let's say we have meeting from first to second hour and 0 to the first hour and another one third to fifth hour and fourth to sixth hour. So the best way that greedy approach starts out with, let's say this is start and this is end hour. So the in case of greedy, it checks the start hour. So this would be the first one. So this gets picked. This meeting gets picked. Meeting M2, M1, M3, M4. Right. So the greedy approach takes M2 as a first meeting to be attended, followed by M1 because 0 is the starting hour, which is less than that of any of the other meetings, and M2 and M1, and then goes M3 and M4. That's the way that greedy approach can be coded. So it is very simple and easy to understand. So yeah, we have many examples that where greedy approach is used, but few common things to keep in mind with a greedy approach is we are always looking at a specific point and the most optimal solution without even bothering about the next steps, which greedy algorithm might fail at certain points, and the dynamic programming solutions will work much better at such problems, right? So yeah, so let's take a few examples. Let's say we are given with a coin change problem. So uh, let's say we are given a minimum set of coins 5, 10, 1, 5, 10, 25, and the minimum coins that we require to make 41, let's say 1, 5, 10, 25, and let's say we are asked to, these are the coins, so we are asked to make 41. So the best way that greedy approach goes about this is, first we go 25 with the coin 1, and this leads us to um, 5 plus 16, so 16. So this would be 16, and the next one would be coin 2 uh, will be of a minus of 10, which would lead us to 6, and this again goes out to c c3 coin of 5, which would mean 6 minus 5, which would lead us to 1, and finally a c4, right? So it requires 4 coins to be uh, exchanged or given out with. So let's look at one example with coin change, and we can understand the simplicity of how we can code this problem out, right? So yeah, let me switch to JSBin and let's quickly look at an example. Okay, so as you see, I have got few descriptions here and a few set of examples, but I've added only 2 examples just to make this video shorter in duration. Coin change example. So let's say we are given with a minimum number of coins like 1, 5, 25, etc. Greedy strategy, and we are required to give an amount of 41. So the way that this problem works is we need to give 25 at the beginning, 10 at the 10 next, and 5 next to satisfy the value of 41, right? So here is a simple solution for the same in greedy approach. So we sort out the coins in ascending order, and we also keep the count of number of coins that we want to change and the remaining amount subtracting with each coin that we change with, right? Coins used also is something that we push out to. So with each coin remaining, if the value remaining uh, amount is greater than or equal to coin, so then we consume that coin and we subtract the uh, amount value with the coin that we just changed with, and we increase the count saying that we already gave out a coin. So that's the whole idea here, right? So if remaining is equals to 0, then we give out the number of count of coins that we exchanged and the coins that we used, that we push it into this array, right? So here, as you see, the coins are sorted in a descending order. Uh, like the biggest coins are placed first and then the smallest ones, so that we can use the largest coin as a greedy approach, right? So that's a simple explanation. There is also another example that I have placed here with activity selection, the one that we discussed. Do check this out. Do check this code implementation, and also do post your thoughts or questions in the comment section, right? So I have also pasted few notes here on greedy versus other approaches. So let's say we have coin change and such things would be easy, where we are asked to find a most optimal path at a specific point. Those are where greedy algorithms perform the best, while it fails in case of problems where we need to bring out the uh, traveling salesman, or places where dynamic programming or the best optimal solution works. uh, the greedy approach fails, right? So it is always consider greedy is just like at a specific point we are making a best decision, not knowing what the future of that path takes, while backtracking and dynamic programming help us find the most optimal path, right? So that's one thing. Greedy approach is obviously simple and intuitive, efficient to code also. Uh, the limitation is it's not always optimal, because the rest of the nodes in the specific path that we choose at a point is not known, right? We may need to fall back, which dynamic programming or backtracking does this better, right? So I've also pasted other examples that we can take a look at in greedy problems, right? Okay, so I will stop this video for now. So hope you got a glimpse or a general understanding on what a greedy strategy, and two examples that I pasted here, very simple ones. There are, of course, there are plenty of examples which I did not add into this video, but yeah, you can check them out, and please do post what kind of problems that you have solved in the comment section. Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.